friends, welcome to my YouTube channel Echo Aftab. In my today's session, we will see a new topic and that is set theory. Myself, Aftab Bhai. So let us see what do you mean by set theory? Meaning of set theory. Friends, George Cantor, a German mathematician, initiated the concept theory of sets or popularly known as set theory. Set theory is a branch of mathematical logic where we learn sets and their properties. So in set theory, what do we learn? In set theory, we check out what are sets, what are properties. One slide uh, I'll deal with one example where how set theory is related to economics. So a set is a collection of objects which is also called as elements. Set is the collection of objects and those objects are also called as elements. Sets are represented in two ways. There are two different ways through which we can look at sets. One is called as the roster form where we make use of brackets and these brackets are called as curly brackets. And the second one is set builder form where we put on the condition as to what type of elements are there in the set. So first roster form, it's plain set where whatever items are there in the set or elements are there in the set, that is written. Second one is a set builder form, and most of the time we make use of set builder form when we are speaking about infinite number of elements in the set. So these are the two things. So most of the class will be dealing with roster form of sets. Here and there I'll come across set builder form. Having understood what do you mean by set theory, let us see the different example of sets. So this we can call a set of cars, set of boys in a class or set of girls in a class. Set A may be set of boys, set B may be set of girls. Set of cards, a set of red cards or the set of cards which are diamond, a set of all the cards, universal set. So this way we can represent different set. Set of cards here, set of A cards, all the even cards, set of B cards, all the odd cards, all those things we can write. One more example is set of odd numbers 1, 3, 5. So this 1, 3, 5, the bracket closes. So this is the finite set where we are speaking about three elements in the set, and these three elements are having a particular property and they are called as odd numbers. Similarly, set of even numbers, set of vowels. In English language, we are having specific vowels A, E, I, O, U. So finite number of vowels. So set of vowels, set of natural numbers. So when I say set of natural numbers, as we understood in our previous session of number system, here the natural numbers start with 1 and it goes on and on and on till infinity. No end for this number. So this is called as infinite set. These are finite set, these are infinite, and this infinite set can be written in a set builder form. This is set of A where x belongs to all the. So this is an example of set builder form. Going ahead, having understood the different examples where we speak about set, so here there is one word that is commonly used when we refer to mathematics textbooks. The terminology is cardinality. What do you mean by cardinality? The size of finite set is also known as its cardinality. So you can count the number of elements a set contains. Cardinality is measured by the number of elements a set contains. In the previous examples we saw 3 car. So 3 cars matlab cardinality is 3. 4 boys. Cardinality is 4. 5 ovals, A, E, I, O, U. So the cardinality is 5. So number of elements, many times we refer to it as cardinality of a set. Now let us see which are the different types of sets. Empty set. The name itself will tell us what it means. Empty set is a set where we have no elements. The set which has no elements is called a null set or void set. It is denoted by curly brackets without anything in between the brackets. The bracket nil, that is what is called as empty sets. So set of numbers, can you give an example where a number is both a even number and an odd number? Is it possible? No. So no number is both an even number as well as an odd number. So the set of both even and odd will be null set. Can you find a fruit which is both apple and orange? No, the fruits will be either apple or orange. So set of apple and orange is a empty set. So these are the two examples. Here friends, but I'm speaking about one particular element x which is both even and odd, and this type of items we don't find in the, because of that empty. Similarly, if I say y is a fruit which is both apple and orange, so no fruit is both apple and orange. There are different fruits which can be apple or orange. So given the set of apple and orange in a fruit is a null set or empty set. Then the second type of set is singleton sets. Singleton in the sense the cardinality of the set is 1. There is a single element in the set. The set which has just one element is named as singleton set. Example, set A is equal to 5. So here 5 is a single element. Similarly, set B is A. So here both set A and set B, we can call them as singleton sets because there is only one element in the set. Moving ahead, having understood empty set and singleton set, the next one is finite and infinite sets. The set which has a set that has a finite number of elements is known as finite set. Any set which has a finite number of elements, here we are speaking about finite number of elements, that is known as finite set. Example, set A 1 2 3 4 5, set B A E I O U. So what is the cardinality of set A? There are 5 elements. What is the cardinality of set B? There is also the cardinality is 5. These sets, you can count them and they are finite in number. So they are called as finite sets. Next is the set whose elements cannot be counted is known as infinite set, or the set where we don't know the cardinality is called as infinite set. Example, set C, number of cats in India. Do you know how many cats are there in India? No. Set D, number of stars in the sky. Can you count the number of stars in the sky? No. So this type of examples comes under the category of infinite set. So this is one more type of set, finite and infinite sets. Next one is equal sets. What do you mean by equal sets? If every element of set A is also the elements of set B, and if every element of set B is also the element of set A, then we say that set A and set B are equal sets. See the example? Here set A has 5 elements. The cardinality is 5, and which are the elements? 1, 2, 3, 4, 5. Similarly, in set B, there are also 5 elements. And what are the elements? 5, 4, 3, 2, 1. So we are saying that set A has, in set A we are having element which, set B also we are having, set A has an element which is 2, set B there is an element, set A has 3, set B 3. Similarly, 4 is there in set A, 1 it is, 5 is there in set A, there in set B. So we can say both set A and set B are equal sets. So what it is saying, if A is also the elements of set B, and if every element of set B is also the element of set A, then sets A and B are called as equal sets. So this is one example of equal sets. Moving ahead, there is something called as power set. Now what do you mean by power set? The power set is a set wherein all the subsets are included. Now the question comes, what do you mean by subset? I'll tell you about it, what it is. So in this, you'll understand what subset means. So it can even be empty set and the original set itself. So see here friends, the example for us to understand what is power set and automatically understand what is subset. So if I say there is set A, 1, 2, 3. So out of these sets, how many sets we can say, we can create? So here set A is there, 3. So if I take one element, set B, I write in this we are having 1. Similarly, I take one more set C. Here I'll write as 2. Similarly, I'll make one more set D. Here in this set I will write 3. Similarly, I'll write set E. Here I'll write 1 and similarly I'll write set F. Here I'll write 1 and 3 and so on. So this different sets, they constitute to be, this is example of subset. So set B, set C, set D, set E, set F and another two more sets that will come, all come the set A, and this also includes one more set, that is set Z, that is where there are no numbers. So even the empty set comes under set A, and set A itself comes under the power set. I hope you understood. Just check it out. Then all the sets such as set of only singletons 1, 2 and 3. Then set where we are having 1, 2, 1, 3, 2, 3, and sets where 1, 2, 3 the original set itself along with the null set are all the elements of power set. So as I explained it over here, now you can see how we write the power set. So power set is written as power set of E is equal to all these sets. That is what is power set. Then comes universal set. A universal set is a set which contains all the elements or objects of other sets, including its own elements. It's very tough or it may be confusing for us to understand what is universal set to read the, but if you see the example, it will be clear. It is usually denoted by the symbol U. Example is, if I say set A is 2, 4, 6 and set B is A, E, I, O, U, then the items that are there in set A and the items that are there in set B, if you take all the items together, then it is called as universal set. You can see here on the slide 2, 4, 6 and A, E, I, O, U together, they form union, universal So universal is a set which contains, as I said, all the elements of other sets including its own element. So set A is 2, 4, 6. Set B is A, E, I, O, U. So universal set all the elements of other sets. So universal set all the elements of set A, all the elements of set B together constitute universal set. Next is subset. As I told you, if all elements of set A in another set B, then set A is said to be a subset of set B. If all elements of set A are in another set B, then B is more broader, and in that if we are having A, then A is said to be subset of B, or B is said to be superset of. So A is a subset of B, and how it is denoted? A is subset of B. This is the notation for subset. A is a subset of B, or you can say B is a superset of A. Example, I'll take the example here. Set A is all the natural numbers. You have studied in the number system. Set A is natural numbers, and set B is whole. Friends, if you want to know what are natural numbers and whole numbers, the iCard here, number system, about what are natural whole numbers. Now coming back, set A is natural numbers and set B is whole numbers. So as we have seen, if you limit yourself only for the counting numbers 1, 2, 3, it is natural numbers. Whereas if you bring into 0, then 0, 1, 2, 3, 4 is whole numbers. So whole numbers include natural numbers. Please see my sentence. What I am saying is whole numbers include in them natural numbers, or you can say natural number is the subset of whole numbers. So if this is the red circle is natural numbers, the black circle is the whole numbers, then how we can represent this particular notation in the form of a Venn diagram. So here I am introducing to you Venn. Friends, what do you mean by Venn diagram? So Venn diagram shows us pictorially how the sets are interacting with each other. That is the specialty of Venn diagrams. The Venn diagram is widely used in a diagram style that shows the logical relationship between sets. So Venn diagram shows the relationship between the sets. What type of relationship? Logical relationship between the various. So now here the two sets under consideration is set A and set B, and we are saying what type of relationship this set has in terms of the concept called as subset. So to understand subset, we are making use of Venn diagram where there are two different sets. Set A is natural numbers, set B is whole numbers, and how we can show it diagrammatically? You can see. So all the elements of set A are also the elements of set B, but set B has more elements than set A. So 0 is included in set B, so it is whole numbers, whereas in set A it is only natural numbers. So this is the way we represent subset. So circle A is a subset of circle B, means all the elements of A are there in set. So this is one more category, one more type of set, that is subset. Moving ahead, friends, now we'll come across one of the most important topics when we speak about set theory, and that is set operations. And here we make use of four important operations. Set operations are conducted on two or more sets to obtain a combination of elements. As we know, if we are speaking about two sets and if we are speaking about their logical relationship, we are either trying to add up the sets, or we are trying to subtract the sets, or we are trying to see which are the common elements in either of the sets, or which are the unique elements in either of the sets. So the words that are used, common elements, unique elements, adding up or subtracting, so these things we call this as set operations. And commonly we have four important set operations. I am speaking at an elementary level for us to understand set operations. Four important set operations. They are: first one is called union of sets, second one is called intersection of sets, third one complement of sets, fourth one difference of sets. So let us see one by one what are these four different operations that comes under set theory, set operations. And let us begin with the first one, union of sets. Union of sets is a set which comprises all the elements of both the sets. Union of two sets, it includes all the elements of both the sets. Example, the union of two sets A and B is the set of elements which are in A, or which are in B, or which are in both A and B. So it will be clear with this example. Normally we denote union of sets with this particular symbol, and that is denoted by A union B. This symbol is for set operation, union of sets. Symbolically, this is this noted as E. And here this particular thing is called set builder form, where we are the example in a form of condition. So if A union B, A is one set and B is another set, and if this is an element of set, then this element, it belongs to A as well as that elements belongs to, that is what A union B. Here you can see the union of two sets A and the set of elements which are in A, element belongs to A, or which is in B, elements belongs to B, or it is in both. So an example, set of odd numbers A 1 3 5. One more set, set of even numbers B is 2 4 6. Now what will happen to A union B? So we are taking all the elements of A and we are taking all the elements of B and we are bringing them together. So you can see here how we are going to solve this A union B for set of odd numbers, for set of even numbers. A union, so A union B is all the elements of A 1, 5, 5, and all the elements of set B 2, 4, 6. This is A. How we can write this thing? A union can be written as 5. So 1, it belongs to set A. 2, it belongs to set B. So one more thing was there, either A or B or both A and B. For that sake, I can write an example. Let us say set A is 1, 2, 3, 4. Set B is 3, 4, 5, 6. So now what is A union B? A union B is all the elements of set A, 1, 4, and all the elements of set B. Already we have taken 3 and 4. So remaining 5, you can see here 1, 5, 6 becomes the A union. So here 1 belongs to A, 2 belongs to B, 3 belongs to both. It can belong to A or it can belong to B. Similarly, 4 can also belong to A, can belong. This is what is union of sets. Let us see in the form of Venn diagram how we look at union of sets. So this is set A, 1, 3, 5. This is set B, 2, 4, 6. So here we are having 1, 5. Here we are having 2, 4, 6. Now when I speak about union, what will happen? I am bringing both the sets together and making them one. In that case, so two sets have come together. So you can see a Venn diagram where I am bringing set A, that is circle red, set B, that is circle B, the set E, which is circle blue. This thing you can see, this is all the elements. 5. This is called. I hope friends it is clear. This is set A union set B. So simple union means we bring all the elements from all the different into one single set. This is going giving us a new set with all the elements. Moving ahead, let us see what are the properties of union of sets. First one is commutative property or commutative law. Here A union B is same as B union. This is one particular property. Example, if I say set A is 1 and 2 and set B has 3 elements, the cardinality is 3, 2, 3, 4, then A union B will give us 1, 2, 3, 4, or B union A will give us 3, 2, 3, 4, 1, and you can see both the sets A union B and B union A has the same cardinality, and because of that we say A union, same thing applicable for other operations. Similarly, the second property is associative law. It means A union B union C is equal to A union B union C. So here the distributive property also works. Example, if A is 1, 2, B is 2, 3, 4 and C is 1, 4, 5, then first we'll make A union B. First we'll try to find out A union. What is A union B? A union is 1, 2 is already there, 3, 4. So A union is 1, 3, 4. Again further we are trying to see A union B union C. So what is C? C is 4, 5. Now let us see what will happen to the entire set A union B union C. So 1 the 1 the 2 3 4 is in both the things, so I'll take it 1 5. So A union B union C is 1 2 5. Is it the same as this thing? So let us see B union C. B union C is 1 2 3 4 is common and 5. So 1 2 3 4 and 5. Now this thing we are going to unite it union A. What is the elements in A? 1. So now A union B, the entire, what will get? 1 and 2 is there, 1 and 2 is there. So 1 4. So both the sets, are they not equal to each other? Yes, they are equal to each other. That is why, right, A union B of set union C in the same way as A outside, that is A union B union C. Same thing. A union is union C comes 1 2 3. Similarly, B union C is 2 4 5. Union A is 1 2 3. Both the elements same, and that is 40 of set. Going ahead, the next important set operation is intersection of sets. The intersection of sets A and B is the set of all elements which are common to both A and B. Here we are speaking about only those elements which we found it in A, and that is what is called as intersection. It is denoted by inverted U. This is the notation for intersection. If this notation is for union, then this notation for intersection. What union says? It says all elements. What intersection says? Same element. That is the difference. So A intersection B in the set builder form, we can write this element E belongs to A and the same element E also belongs to B. Here there is no OR. Here there is AND. If it is OR, it is union. Here because it is AND, intersection. Hope it is clear. Let us see an example. I have written set of odd numbers A1, 3, 5 and I have written set of even numbers B2, 4, 6. Now tell me the elements which are common in. Do you find any element which is common in both? Common in A, B? Your answer will be no, sir. There are no elements which we find in both. So can I say A intersection B is, it means null set or empty set. This is the example. See, A intersection B of odd numbers set and even number set is going to give us empty set. There is no element. We'll take one more example. Set of odd numbers A is equal to 0, 1, 2, 3. Sorry, this is odd numbers. Let us take set of numbers where A has elements 0, 1, 2, 3 and set of another number, not odd anyone, set B, which has 2, 3, 4, 5. Now, if I ask you what is A intersection B, you will find that is what is common in A and common in B. So 0 is not there in A, not there in B. 1 is in A, not in B. We found, yes, this one particular element common in set A, set B. Similarly, this particular element is common set A. 4 is only in B, 5 is only in B. So 0, 1 it is found only in A, 4 and 5 it is found only in B. There are only two elements, 2 and 3, which we find it in both the. So 2 and 3. So A intersection B is equal to 2. A intersection B is 2. Let us see the same thing in the form of Venn diagram. So when I bring intersection property or set operation, how it will look? Set A and set B, there is only a small area where you can see both the elements are common. So only in this particular area you can see 2 is there, 3 is there, and here we find 0, here we find 4, and so 0, 1, 2, 3 is coming in red circle. Similarly, 2, 3, 4, 5 is coming in blue circle. Red circle is related to set A, blue circle is related to set B. There are only two elements which are coming in both the circles, that is 2 and this 2 and 3 are common to set A, set B, and that is the part of intersection. Yellow shaded area is our intersection. This is shaded by A intersection, this A intersection we are having 2 which is common to A and B, and 3 to. So with this we'll come to the next part, properties of intersection set. Again the same properties what we saw in union. There it was A union B is equal to B union A. Here it is A intersection B is equal to. In the same associative law, A intersection B in turn intersection with C is equal to A intersection B intersection. So you can have your own examples and try to work out this particular of intersection of sets. Moving ahead, complement of set. So here what do you mean by complement? The complement of the set is defined as the difference between universal set and the set itself. What is universal set? So if universal set U is having a subset A, if universal set U is having a subset A, then what is complement of A? Complement of set A, it is represented by A dash. So complement of set A is A dash, and it is other than the elements of set A, which includes the elements of the universal set but not the elements of set A. So whatever is there in set A, excluding that, whatever is there in the universal set becomes complement of set A. So in the form of set builder, we see A complement is equal to an element X belongs to U, but that element does not belong to A. That is what I said. It belongs to U, but it does not belong to. So any element that is there in the universal set but not there in the set A, then that becomes complement of A. In other words, the complement of a set A is the difference between the universal set and set A. Universal set U minus set A. That is what is. So you'll understand it with the help of a numerical example. Let us say set of numbers U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So let us say this is the universal set, and there is another set, and that is set of even numbers. A is 2, 4, 6. Now, what is the complement of set A? So, complement of set A is all the elements of universal set which are there but not there in the set A. So 2 is there, 4 is there, 6 is there. So what all things are not there? We don't have 1, 3, 5, 7, 8, 9. So this becomes the complement of A. So we write it as A dash is equal to U minus, here U is universal set minus set A. So as I said, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all these things there, minus set A, 2, 4, 6. So 2, 2, 4, 2, 4, 6. So excluding this, whatever is left, A dash is equal to, see carefully, when I pull down sets, I have pulled only those sets, those elements that are there in universal set, but not including the red dot down black digits. What are these black digits? They are in universal set. Find them. That becomes complement. Universal set U, set A. Set A, the subset of Venn diagram. All the elements that we find in U but not there U, anything that is there in A, 4, 6, and all the other things that are there in U but not there in complement of E. Now comes difference of set. The difference of set, or you can say difference of two sets A and B, is defined as the list of all the elements that are in set A but that are not present in set B. It is similar to what we saw. It is similar to what we saw as set notation as A minus B in the previous set, where we spoke about universal set minus A set. This is the same reasoning, same logic. Here A minus B is X is an element, X belongs to A and X does not belong to B. X is in A but it should not be there in. This is the difference between two sets. In other words, the complement of set A is the difference between the universal set and set A. So what we saw in the previous slide, the same logic is applied here difference of sets. So you can see here now, when I speak about difference of sets, an example, set A is 1, 2, 3, 4, 5 and set B is 3, 4, 5, 6, 7, 9. Then A minus B is all the elements of A minus all the elements of B, and what is left out is, so 3, 4, 5 is there in A, and the same 3, 4, 5 is also there in B. So excluding those sets, only the sets that we find in A, we take it into consideration, because we are speaking about A. Is what will happen if I speak about B minus A, friends? So B minus A will be 1, 2, 3, 4, 5 minus 3, 4, 5, 6, 7. So here, what is there in B but not there in A? We can see here, when A minus B, 1 and 2 is not there in B. Similarly, B minus, we see that there is 6, 7 and 9 which is not there in A. B minus A becomes 7. So this is how the difference of sets. So what we understood by this example, A minus B never equal to, because A minus B we got what, 1, 2, but B minus A what we got, 6, 7, 9. So this particular point you have to remember. What difference of set? So A minus B is the set of elements of A that are left out. So if this is set A and this is set B, and A minus B is only those elements which purely belong to A but are not there in B. This particular part, A exclusively in A, not found in B. This is what is different. So where does set theory comes into the picture when I am speaking about it in economics? I'll just give you an example, friends. Let us say you have income of rupees 200 and you have two commodities or two fruits. One is apples, the other is mangoes. Let us say that the price of apple is rupees 2 and the price of mangoes is 4. Now, how can you represent it in such a way that you have to buy both the commodities, and the amount that you spend on apples and oranges should be equal to 200 or less than 200? So if you want to write this thing in the form of an equation, it will be something: 2 apples plus 4 mangoes. 2 is the price of apples and 4 is the price of mangoes, will be less than or equal to 200. So this thing that you have written, 2 apples plus 4 mangoes, will be less than or equal to 200. And I call this thing as budget set. So can I say set of apples comma mangoes, the condition is 2 apples plus 4 mangoes should be less than or equal to, and here x cannot be negative, it has to be equal to or more than 0. Similarly, x in the sense apples. Similarly, even mangoes you can buy no quantity or something more than. So this set builder form of budget. This is how make use of set theory in economics. This is just a small example to tell you about budget set. Similarly, we can have sets with regard to optimum utilization of firm's resources. We can have set builder for production analysis with regard to labor and capital, set of labors and capitals giving us an uh, output. So different levels of labor and capital, plus different levels of output. So all these things can be represented in the form of. That is the reason set theory is useful to us and is also important for. This is the reason mathematics, and because of this we are trying to understand the different concepts of mathematics that we apply in economics. And here comes mathematics for economics. Remember friends, studying economics theoretically will just give you the knowledge, but studying economics, the base of mathematics, will create your analytical skills, create your problem solving. Also, it will help you to develop, build up solutions for various problems. Economics without mathematics, body without soul. Now let us see one more thing. One simple, I'll solve one or two examples to see how the interaction of union and intersection works out. That I'll stop my class. So let us see few problems. So the first problem is, if I say there is a set A which has 4 elements, the cardinality is 4, 2, 3, 4, 5, and there is set B, it has 3 elements, 3, and there is one more set, set C, which has 5, 6, 7, 8. Now if I want to solve for this particular operation, A union B intersection B union. So if you want to solve for this, how are we going to solve it? So friends, let us start first with A union B. So A union B is all the elements of A and B are, so 2, 3, 5. So this is A union. Similarly, B union C. So B union C is 3, 5, 6 is there common in both. So I'll take it 1, 7, 8. So we got A union B, we got B union C. So 2, 4, 5, 6, A union B, intersection B union C, 3, 5, 6, 7. Now when I speak about intersection, it means only those elements which are common in both. Remember, we are speaking about common elements. 3 is there in their auto. 5 is there here. Here also we 6 is there here. Here also we 6. 9 is over here. So can I say the common elements 3, for you. This normally they do this, ask us solve for this set. This is one example. Another example, friends, just for the sake of practice, if I say there is set A, set A is equal to, the elements are 2, 4, 5. Set B is having 3, 6, and set C is having 5, 6, 7, 8. Now the question is, find out A intersection B union C. So if this is the question, what we can do it, we have to first find out what is B union C. So friends, B union C is 3, 5, 6, 7, 5, 6, 7. Now what is set A? Set A is 2, 3, 4, 5 intersection B union C. B union C is 3, 5, 7. So here we need to see what is common. 3 is common. Anything else? Yes. 5 common. Nothing else is common. So our answer will be C. So this is all about sets. I hope you understood with the help of this single problem. Many times we will be having different examples when we speak about set. Different types of questions are also there, so that you can practice. For example, if I say there are people in a village, few people who drink coffee, few people who drink only tea, there are few people who drink both tea and coffee, and there are few people who neither drink tea and coffee, and the numbers are given. And with the help of this set operations, intersection and union, we can find the population of that particular village. So this is how we come across different applications of sets in real life as well as in economics. So friends, with this we have come to the end of the class, and thank you for being with me. Thank you for watching Understanding Economics with Professor Aftab. So be in touch with me, keep watching my videos, keep sharing my videos, keep liking my, and if you like my videos, please subscribe to my channel O Aftab. So till my next class, take care of yourself, stay happy, be happy. Tata, bye bye.